Hello everyone, today we are going to see about the chemical bonding and molecular structure, and first we are going to see about the introduction. First I explained that what is chemical bond. So the interatomic attractive force which holds the constituent ions or atoms is together in a molecule is called the chemical bonding. Why do atoms combine only in a certain combination to form a molecule? For example, take an oxygen. Oxygen combined with the hydrogen, so it gives a water, so H2O. So another example for the oxygen is combines with the carbon, so it gives the carbon dioxide, CO2. So next, the structure of the water is a V shaped, so it is a carbon dioxide is a linear. Next we are going to see about the Herschel Lewis approach to chemical bonding. The logical explanation for a chemical bonding was provided in the Herschel and Lewis in 1916. So the element then noble gases try to attain the completely filled electronic configuration by losing, gaining, or sharing or one or more electrons from their outer shell. So for example, sodium loses one electron to form a nitrogen plus ion. So and chlorine accept that the electron, so to give the chlorine ions, chlorine Cl minus. So Na plus and Cl minus held together the electrostatic attractive force. So and the attractive force is called the chemical bond. So and next we are going to see about that. He introduced the Lewis he introduced simple scheme of represent the chemical bond and electrons present in the outer shell of an atom. So it is called that Lewis dot structure. For example, Lewis structure of, I will give a for example Lewis structure of nitrogen atom. So first four valence electron are denoted as a single dots, so around the four sides of the atoms atomic symbols, and then fifth onward the electrons are denoted as pairs. For example, the electronic configuration of nitrogen 1s2 2s2 2p3. So it has a five electrons in its outer shell. It is the outer shell valence shell. Valence shell is the Lewis structure of nitrogen is as follows. And next we are going to see the octet rule. Octet rule, the idea of the Kochel and Lewis approaches to chemical bond to lead the to lead to the octet rule, so which state that the atoms transfer or share electrons, so that all atoms involved in the chemical bonding, obtain 8 electrons in their outer shell. So first next we are going to see about, this is the octet rule, and next we are going to see about the types of chemical bonding. There are two types of chemical bondings. One is the covalent bond, another one is the ionic bond. So it is how to classify means nature of the interaction between the bonded atoms. So two types. One is already I say covalent bond and ionic bond. Generally a metal reacts with a non-metal to form an ionic compound, and the covalent bond are present in the compound formed by the non-metal. And first type one is covalent bond. Lewis suggested that both hydrogen atom will attain their stable or sharing one or more electrons from their outer shell. And next, the covalent bond. Lewis suggested that the both hydrogen atom will be attain the stable configuration, mutually sharing the electron available with them. So similarly, in the case of oxygen molecules, both oxygen atom share 2 electron pair between them, and nitrogen molecules 3 electron pairs are shared between two nitrogen atoms. So this type of mutual sharing of one or more pairs of electrons between two combining atoms result in a formation of a chemical bond is called the covalent bond. So first the figure you see that first one is a single covalent bond, and second the oxygen molecule O2 is a double covalent bond, and third one is the example for nitrogen molecule N2. It is a triple covalent bond. So These are the types of covalent bond. And another one is the ionic bond. What is the ionic bond? An ionic bond is formed by the complete transfer of some electron from one atom to another atom. So the atoms losing one or more electrons becomes a cations. Cation is a positively charged ion, and atom gaining one or more electron become an anion, the negatively charged anion. This is the example for this is the example for ionic bond. Next, we are going to see about the bond parameter. What is bond parameter? The covalent bond is characterized by the parameters such as first one is the bond length, and second one is the bond angle, and third one is the bond order. And first one, the bond length. What is bond length? So the distance between the nuclei of the two covalent bonded atom is called the bond length. Okay, and consider how to consider the covalent molecules A minus B. If you see that the figure, the bond length is given the sum of the radii of the bonded atom or A plus or B. Therefore, R1 plus or B. The length of the bond can be determined by spectroscopic, X-ray diffraction, and electronic diffractions, and the bond length depends on size of the atom and the number of bonds multiplicity between the combining atoms. This is the bond length. And next we are going to see about the bond order. What is bond order? Number of bonds formed between the two bonded atoms. Okay, number of bonds bonded with the two bonded atom of in the molecule, it is called the bond order. Now, Lewis theory say that the bond order is equal to the number of shared pair of electrons between the two bonded atoms. For example, hydrogen molecules, there is only one shared pair of electron, and hence bond order is 1. So similarly, H2O, HCl, methane, etc. So the central atom forms single bond with bond order of 1. Okay, and next one is the bond angle. Covalent bonds are directional in nature and oriented in specific direction in space. This is the bond angle. The direction nature creates a fixed angle between the two covalent bonds in a molecule, or this angle is termed as a bond angle. So usually expressed in the degrees. Bond angle is usually expressed as a degree. So bond angle can be determined by the spectroscopic method and give some idea of the shape of the molecules. And for next topic, you see about valence shell electron pair repulsion is a VSPER theory. Lewis concept of structure of molecules, it deals with the relative position of an atom in a molecules and sharing of electron pair between them. We cannot predict the shapes of the molecule using Lewis concept. Lewis theory is combination of with VSPER theory will be useful in predicting the shape of the molecules. And we have to see about the we see about the shape of the molecules, structure of the molecules. First one we see first one is the Benn model is a trigonal planar. Okay, trigonal planar. The total electron pair is 3, and number of bond pairs is 2. Number of lone pairs 1. The geometry of the molecules or ions bend. And next we are going. These are all that. These are all that of shape of the molecules. And next we will see about the hybridization. Hybridization is a process of mixing of atomic orbital of the same atom with a comparable energy to form equal number of new equivalent orbital with the same energy. The resultant orbital is called the hybridization orbital. The types of hybridization and geometry of the molecules, and first one is the sp hybridization. So for example, beryllium chloride, and second one is the sp2 hybridization. Is for example For example, boron trifluoride, sp3 hybridization, for example CH4, sp3d hybridization, for example PCl5. And second one is the molecular orbital theory. The Lewis concept and valence bond theory, Lewis concept and also valence bond theory qualitatively explains the chemical bonding, so chemical bonding and molecular structure. So both approaches are to describe some of the properties of the molecules. For example, this theory predicts the oxygen is diatomic. So first one is bond in some homonuclear diatomic molecules. This is the MO diagram of the H2 molecules. So this MO diagram, it gives that the electronic configuration H atom is 1s1, and the electronic configuration of the H2 molecule is a sigma 1s2. So bond order, how to calculate the bond order? Np minus Na divided by 2 is equal to Np minus Na is equal to 2. So 2 minus 0 divided by 2 is 1. So molecules have the no unpaired electrons, hence it is the diatomic. And next one is the MO diagram of the C2 molecules. That's all. These are all the bonding of the homonuclear diatomic molecules. Hope you all understand. Thank you.